Today we're going to learn about a special part of a circle called a tangent. Our tangent and secants, and then we're going to classify common tangents and tangent circles. And then we're also going to look at something called the law of contradiction. Intersect that circle in 2 points. Plane of a circle, but instead of intersecting the circle in 2 places, it's only going to intersect that circle in 1 place. Yep. So that point of tangency, so a point of tangency, first of all, is a point, is the point at which that tangent line intersects the circle. Secant and a tangent. So, of course, the line MN would be our secant because it's intersecting the circle at 2 points. And then we have the tangent line FG, where our point of tangency is point F. Tangent to a circle, then it's going to be perpendicular to the radius that is drawn from the center to that point of tangency. So if you draw a radius to that point of tangency, it's going to be perpendicular, okay, which means that these are 90-degree angles here. So we have a theorem that's called the law of contradiction. And so what the law of contradiction is, it's a way to prove things. So basically what you do is that you make an assumption, and if that assumption leads to a contradiction or something that's crazy or something that doesn't make sense, then that means that the opposite of the assumption or the negation of that assumption is going to be the truth, okay? On the circle, then that line has to be tangent. So that's the opposite of that other theorem that we had talked about, theorem 9.4. And here is a line that is perpendicular to the radius. So if your line is perpendicular to the radius, then it has to be a tangent line at a point of tangency. Circles are going to be congruent. Xn, right? And those are coming from the point X. They're coming from the extended point at X to the circle. So we're going to say that those tangent segments are congruent. So Xm is congruent to Xn. Line that's tangent to 2 different circles. You also have something called tangent circles. So tangent circles are the circles that are on that tangent line. So they're on that tangent line and they're on that line at the same exact point. So they share a point of tangency. Tangents are classified as internal if they intersect the segment joining the centers. So line A, which is this tangent line here, and line D, which is this tangent line here, we call those internal tangents because they cross the line that connects those centers of those circles. Whereas tangent line B, so now tangent line B connects those circles, and tangent line C also is tangent to both those circles, but notice that it's not going across. So we just call those external tangents. tangent circles, and those are going to be on opposite sides of the common tangent. Here are some circles that are all tangent to this tangent line right here. Okay, and so notice that circles P and M, here's P and here's M, those are externally tangent because they're on opposite sides of that point of tangency. Versus circles N and M are internally tangent because they also share a point of tangency, but they're on the same side of that point of tangency. All right, go ahead and try some problems on your own.